Chapter 11 looks at intermolecular forces, which are the forces that hold molecules together in a substance. So forces that are between the molecules. And these affect many of the properties that we'll see in this particular chapter, such as boiling point, which also affects what phase that substance is at a particular temperature. When we look at the phase, we're talking about whether or not something is a solid, a liquid, or a gas. And there's a couple different ways that we can move between these different phases. So one is through temperature. So if we cool a substance, we can adjust it or decrease the amount of energy those particles have in order to go to a phase that has less movement. So if we cool our gas, we can form a liquid. If we cool a liquid, we can form a solid. Now, this is the way that we're most used to adjusting between phases. However, we can also use pressure. So pressure helps to move the molecules closer together so that the forces between them become stronger. So if we increase pressure of in the container of a gas, we can force those molecules closer together. By increasing the pressure, we can also form a liquid. If we reduce the pressure on a liquid, we can give those molecules more room to move and therefore become a gas. So why are molecules attracted to each other? Well, it has to do with the intermolecular, so between the molecules, the attraction that they have. And this happens because of opposite charges. Now, it could be a positive, negative ion that are attracted to each other, or it could be just from the fact that a molecule is polar. So if we have a more positive end of a polar molecule, it gets attracted to the more negative end of a polar molecule. For example, we have water, so our hydrogen, we put a little delta, partial positive for the hydrogen, and our oxygen is a partial negative, a little delta negative, and they are attracted to each other because of the difference in charges. Now, even if we have non-polar molecules, there will be temporary charges that happen. And so we'll talk more about that when we talk about the types of intermolecular forces. Now, the structure of the particles determines the strength of the intermolecular forces, and those intermolecular forces determine the state of the substance. So the larger the charge, okay, the larger the difference in the charge, the stronger the attraction is going to be. This is going to hold the molecules tighter together and make it more difficult to overcome those intermolecular forces. Helps to resist the movement of those molecules. So the stronger the intermolecular forces, the higher the boiling point of the liquid. So this is one factor that is affected by intermolecular forces, is the state of the substance. Now, these are a longer distance, weaker attraction when we're looking at intermolecular forces. So in our water molecule, the attractive forces between the hydrogen and the oxygen inside the molecule are about 96 picometers. However, the attractive forces that are in between the two water molecules are a much larger distance. So we're talking about 300 picometers. And so because it's a longer distance, it's a weaker attraction than what we see in the bonds found inside the molecules. So they're generally smaller charges and they're over much larger distances. So the kinds of attractive forces we're going to talk about are intermolecular forces, are dispersion forces, which happen from a temporary polarity in a molecule, And that happens when there's an unequal distribution of the electrons inside the molecule. There's also dipole-dipole interactions, which happens in a polar molecule. So it has to be a polar molecule in order to have dipole-dipole interactions. And an especially strong dipole-dipole attraction happens when we have a hydrogen attached directly to a very electronegative atom, and these are called hydrogen bonds. And the types of electronegative atoms that are found are oxygen, fluorine, or nitrogen. So when hydrogen is directly attached to those, we can form hydrogen bonds.